In this lesson, you will learn how to create a modified box plot given a set of data or a computer output. You will also look at how to describe the distribution of a given box plot, as well as answer questions based on the box plot. Let's take out our notes page and look at the last row down at the bottom of the first page. Remember, you can reference a separate note-taking lesson for describing distributions if you need a refresher on this. In other lessons, you would have received instructions for adding notes for the rows marked dot plots, stem plots, and histograms. The last row is for the graph at the bottom of the list, box and whisker plot. So when should you use a box and whisker plot? Well, the data needs to be quantitative, just like a histogram, a dot plot, and a stem plot. Box plots are good for small or large data sets, and you can easily see certain statistics about the data set. We'll go into more detail on that in this lesson. Here are the steps for finding a box and whisker plot for your notes page. Number 1, find the 5-number summary for the data set. Number 2, label and scale a number line. Number 3, make the box with the Q1, median, and Q3. Number 4, decide if there are any outliers. Number 5, put dots for any outliers. And number 6, extend the whiskers on your box and whisker plot out to the lowest and highest numbers that are not outliers. This is best seen in an example. So let's look at example 1. Create a modified box plot for the data below that represents the number of movies a group of high school students saw in the movie theater over the summer. We'll work on this together. For step 1, we need to find the 5-number summary, and I've already done that for you. Since I have that, I was able to complete step 4 to show that there is an outlier. Using the outlier formula, I found that there is a number that's higher than 71. So 75 is an outlier. However, the 5 is not, because if I take 23.5 minus the cloud or bubble number, 28.5, it'll be something that's below 5. So I don't have any outliers on the low side. So now let's make our box and whisker plot. In step 2, we need to make a number line and scale the axis. Be sure and label it. In this case, I need to go from 5 to 75, and I have to go in even increments. So 5, 15, 25, 35, 45, and so on, until I get to 75. I know it's tempting to just go 5 to 45 and then just put 75 at another tick mark. But we have to scale our axis to display the data correctly. So now, my box plot consists of the median and the quartiles 23.5 and 42.5. Now, the whiskers are going down to 5 on this side, but it's not going all the way up to 75 because 75 is an outlier. It gets its own dot. So where does the whisker go to? Well, it goes up to the next number that's not an outlier. In this case, 45. Now you have a complete modified box plot. Now I can guess what you're thinking. Will I really have to make a box and whisker plot by hand? Well, the answer is sometimes. Sometimes you may be given statistics instead of a data set, so you need to know how to make it by hand. However, if I give you a full set of data, you may absolutely use your calculator. Let's take a look at how to do that. The first thing you need to do, as always, is input your data. We'll go to Stat, Edit. I've already put the movie data into the calculator. Now what I want to tell the calculator to do is take that data in list 1 and make a box and whisker plot. So think a second. I want to plot the data. So we go to Second, Stat Plot. We now need to tell the calculator, I want you to make a box and whisker plot. Make sure your plot is on. And now we need to tell the calculator what type of graph we want. There are two options of box and whisker plots. One that has dots and one that doesn't. We will always use the one that shows the dots. Those dots represent outliers. If there is an outlier, I want the calculator to show me that. If you use the other box plot, it will not show the outliers. The one that we're using is called a modified box plot. That's the one we'll want. We tell the calculator use L1. We keep our frequency at 1 because that tells the calculator just to count every single piece of data once. The mark is totally your preference. It just tells the calculator, if there's an outlier, which mark do you want me to use? I always pick the big one because it's by far the easiest to see. If you're lucky enough to have a calculator that lets you choose color, choose your favorite. For me, it's blue. Now I want to graph the data. Option 1 is just to hit graph. That really doesn't look like a box and whisker plot. The reason is, this is graphing in whatever window was there from the last thing you did on your calculator. That might not match the window for your current data. For all of us to see the same view, we can use Zoom 9 or Zoom Stat. This adjusts our screen so we can see the data clearly. That looks like the box and whisker plot that I was expecting. And that matches the box and whisker plot that we just did by hand. As you can see, the calculator is a great tool when you're trying to make a box and whisker plot. You'll use this over and over again in the first semester and second semester. So you really want to be comfortable with navigating the calculator. Let's try another example. In example 2, the following represents the football scores in week 3 of preseason NFL games in 2013. I'd like you to A, make a modified box and whisker plot of the scores, and B, describe the distribution of scores. Pause the video to write down your answer, then hit play to continue. Here's the solution to example 2. For part A, this is what the graph of your box and whisker plot should look like. Make sure that you add a label and a scale on the bottom of your sketch. Now let's describe it. Whenever you hear the word describe, you should be thinking socks, shape, outlier, center, spread. The majority of the scores disregarding the outlier are roughly symmetric in shape. Looking at the box and whisker plot, it is evident there is an outlier. If I look back at the data set, that outlier is at 50. Make sure to show the work for this, which was based on the 1.5 times the IQR with the bubble number calculations. And the center of the score is about 24, and the spread, or IQR, is 10.5. Let's look at another example. In example 3, the following represents the computer output describing a set of measurements in centimeters taken during a science experiment on hair growth after taking supplements. The entire data set is not available, but you are told that individuals with the most hair growth had measurements of 10 centimeters, 11 centimeters, and 15 centimeters. Create a modified box plot for the measurements. There isn't a full set of data here, so you'll have to do this one by hand. Pause the video to write down your answer, then hit play to continue. Here's the solution to example 3. What I've done here is highlight what pieces of this table we need to make our modified box plot. I only need what's highlighted. So to do a modified box plot, I need to see if there are any outliers. Well, let's see. To find the IQR, I take 7 minus 4, which gives me 3. 1.5 IQRs is 4.5. There's my bubble number. Well, I know that Q3 is 7. So are there any numbers that are higher than 11.5? Remember, the highest numbers are 10, 11, and 15. That was given in the problem. So 15 is an outlier. Well, what about on the low side? We'll need to take 4. That's my Q1 minus 4.5, and we get negative 0.5. My minimum is 1, so I don't have any outliers on the low side. Now I'll just draw the box and whisker plot. It goes from 1 to 15. I have my median, which is 6. My Q1 is 4. And my Q3 is 7. There's the box. My bottom whisker goes down to 1. My top whisker goes up to 11 because that's the next highest number that's not an outlier. That outlier gets its own dot. Don't forget to label your graph, and then you're all set. Now let's test what you've learned so far with the check for understanding. As gasoline prices have increased in recent years, many drivers have expressed concern about the taxes they pay on gasoline for their cars. In the United States, gasoline taxes are imposed by both the federal government and by individual states. The box plot below shows the distribution of the state gasoline taxes in cents per gallon for all 50 states on January 1st, 2006. For A, based on the box plot, what are the approximate values of the median and the interquartile range of the distribution of state gasoline taxes in cents per gallon? Mark and label the box plot to indicate how you found the approximate net values. In Part B, the federal tax imposed on gasoline was 18.4 cents per gallon at the time when state taxes were in effect. The federal gasoline tax was added to the state gasoline tax for each state to create a new distribution of combined gasoline taxes. What are approximate values in cents per gallon for the median and interquartile range of the new distribution of combined gasoline taxes? Justify your answer. Pause the video to write down your answer, then hit play to continue. Here's the check for understanding solution. Notice in Part A, it talked about marking up your graph. So look at your paper and make sure that you have that box and whisker plot. Here's what you want to see. The median is about 21 cents per gallon. You can see that notated on the graph. The IQR, which is Q3 minus Q1, is about 25 minus 18, which is about 7 cents per gallon. And notice on the box plot, you have Q1 and Q3 notated. In Part B, when I add 18.4 cents, the whole box plot shifts up. That means the median shifts up as well. So that means the new median is about 39.4 cents per gallon. But what happens to the IQR? If the entire box plot moves, the IQR doesn't change. The Q1 and Q3 move, but the distance between them does not. So that means the IQR stays the same. Now let's go to the wrap-up. After this lesson, you should be able to do the following. Given a set of data, create a modified box plot. Given a computer output, create a modified box plot. And given a box plot, be able to describe the distribution and answer questions about it. That's it for this lesson on box and whiskers. Remember, you can review this video as many times as needed for better understanding. Thanks for watching.